So here's our situation, right? This charge is fixed. That is, we've got it on a stick or something like that. I can't move. But this guy's flying in here. It's like, whew, there it is, right? Now, this is positive, that's positive. So they're going to repel each other. The closer this guy gets, the more the force of repulsion gets and the slower they go, right? Both are true. Okay. Presumably it was going faster than 34 when it was very far away. It has already slowed down in getting to 2 meters away, and it's going to slow down even more going from 2 meters to 1 meter away. In fact, in this type of problem, it's easy to write a problem where it actually couldn't even get to 1 meter. In that case, you get like an imaginary velocity. Okay, so let's take a look at this. Okay, in the first picture here, we've got this mass, and it's got potential and kinetic energy. It's moving. And in this picture here, it's also going to have potential and kinetic energy. Okay? So before, in this situation right here, we've got K Q1 Q2 over R1 plus 1/2 mv1 squared, right? And it's just this thing's velocity. This guy can't move, right? And then afterwards, we're going to have K Q1 Q2 over R2 plus 1/2 mv2 squared, a different velocity, right? Okay. So we're going to have potential and kinetic. It's 2 meters away, and it's moving 34, right? And then we're going to have potential and kinetic, and it's going to be moving at a different velocity, and we're solving for that different velocity. So let's plug this in. K times, so K is, of course, our Coulomb constant, right? Okay, so K times 160 E minus 6 times 160 E minus 6 divided by 2 plus 1/2. Our mass is 230 grams, so it's 0.230 times 34 squared. And that's going to equal K times 160 E minus 6 times 160 minus 6, and that's divided by 1. Okay, plus 1/2 0.230 V2 squared. We're solving for V2, right? All right. Let's divide up our space here. Okay, so let's do these. There's like tools down here, so I gotta be careful I don't hit those. Okay, so let's see. Let's do this first term here. It's going to be, let's see, alpha F1, alpha K. I stored that value in the letter K, times 160 E minus 6 times 160 E minus 6 over 2. So this is 115.072 joules. That's this term here. And then let's do this guy. 0.5 times 0.23 times 34 squared. That's 132.94. Okay, and then this term here is going to be easy because all I have to do is that same expression, but it's going to be over 1. So that's 230.144. And then plus 1/2 0.23 times V2 squared. Okay, so let's see. I'm going to do this plus this, subtract that. I can do this. Okay, where is it? There it is. That guy plus this guy minus this guy. 17.868. Okay, so I'm just going to borrow some space here. Okay, so now this expression here turns into 17.868 is 1/2 0.23 V2 squared. All right. right, we can do this. Okay, so times 2 divided by 0.23, that's v squared. Let's take the square root of that. 12.46. V2, so when it gets to here, it's going 12.5 meters per second. Ta-da! 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 All right. Whoo-hoo!